Hello, welcome to Mat-073. My name is Rob Reynolds. Today we're going to be looking at our second section of Chapter 5, and we're going to be exploring LCM's least common multiples, otherwise known as common denominators, and we're going to look at how to add and subtract rationals. Remember, a rational number is nothing more than a fraction. It's a ratio, and by the way, not only is 3/4 rational, 5 is also rational because you can write it as a ratio. And then last, we're going to look at how to simplify combined like terms. So let's look at, first of all, finding a common denominator. So sometimes we can do factor trees. Maybe you've seen those before. I really like the upside down division. It takes up a little less space on your paper and sometimes a little bit more organized. So I'm going to do upside down division. 2 goes into 48 24 times. 2 goes into 24 12 times. Pick any prime number. And prime numbers are 2, 3, 5, 7, 11. Well, those are the main ones, but you can keep going, 11, 13. So just pick any prime number. I usually use 2s and 3s. It seems to be easy to divide by those. And then I can write this as 2 to the 4th times 3. Let's try this again. Using 54 this time. I start with 2 because it's even. Goes in there 27 times, and then I switch to a 3. Goes 9 times, 3, and 3. So again, you can do factor trees if you're feeling a little bit more comfortable with that, but somehow you get down to the prime factorization, and then the rule says choose every factor as many times as it appears in each factor. So I have to look at the purple, and I see that 2 is a factor. So then I try to choose it as many times as it appears. Well, it appears 4 times here and it only appears once, so the greatest number of times it appears is twice. So then again, I look at any factor, and I haven't chosen a 3 yet, but then I have to choose it the greatest number of times that it appears. Well, here it appears once, and here it appears 3 times, so the greatest number of times is 3. And then the numbers get a little bit large, but 16 times 27, I believe, is 432. So what does that mean? That's the least number, the lowest number that both 48 and 54 go into. Don't get that confused with the greatest common factor, which is the greatest number that goes into 48 and 54. That's something different. So again, here's how the book chose to write it out. They didn't do factor trees either. They just listed them all, but they didn't explain how they got them all. But they got the same answer, 432. So we could do that again with the numbers like 6 and 4. But maybe you could just think about the smallest number that both 6 and 4 go into. Well, one strategy is just to multiply them together and get 24, but that's not the least, that's not the smallest. So what I like to do is pick the largest number. Another technique is, does 4 go into 6? No. You double it and double the highest number, which is a 12, and does 4 go into 12? And the answer is yes. So there's the smallest number that both 4 and 6 go into. If you wanted to, we could do this upside down division again. 2 goes in there 3 times. 4 is a 2 and a 2. So I have to choose every factor. So this is a 2 times 3. This is a 2 squared. So I see that 2 appears, so I need to pick it, but I need to pick it the greatest number of times. And 3 also appears, so again, that's 4 times 3 is 12. But sometimes just picking the highest number and doubling it, or tripling it, or quadrupling it, you can quickly find the least common. So again, we do the same thing with variables. Pick a factor like x, but choose it the greatest number of times it appears. So this time 3, and it looks like y appears in each. But the greatest number of times it appears in each factor is only once. So even though there's 2 y's, I'm only going to choose 1 y because that's what's common to both groups. And here's how the author explains it. So let's try this again. Pick the highest number. Does 6 go into 24? Yes. So that's my least common multiple. And then pick x. That appears, but the greatest number of times it appears is 6 times. And y appears, but the greatest number of times it appears is a 4. It's as simple as that. Choose every factor as many times as it appears, but then choose it the greatest number of times it appears in each factor. So the same thing applies for factors. So let's factor this thing because I'm trying to find the least common multiple. So we need to find factors of x squared, our x and x, 2 and 2. This is called the difference of two squares. And then this one over here, factors of 8 that differ by 2 are 4 and 2. Signs are going to be different. The larger term is negative, x minus x plus. So the same rule applies. I'm choosing every factor. So let's see, x plus 2 is a factor, but I have to choose it the greatest number of times it appears. Well, it looks like it only appears once here and once here, so I'm only going to choose it once in my common denominator, or least common multiple, either way. So the least common multiple, I'm choosing x plus 2. It looks like x minus 2 is also a factor, but it only appears once. It appears no times over here. And it looks like I better choose x minus 4, because I have to choose every factor, the greatest number of times it appears in each. So that means the greatest number of times it appears here, and the greatest number of times it appears here. So again, the trick is, even though x plus 2 appears twice, the greatest number of times it appears in each factor is only once. So I only need to choose it once in my least common multiple. And again, here's how the author chose to work it out. So now we're going to look at how to add. Remember, if you've got a common denominator, you just rewrite that denominator and add the numerators. Same thing for subtraction. Just keep the common denominator. So here the common denominator is w, and all I need to do is add 5 plus 6 plus w, and end up with 11 plus w over w. And one of my pet peeves is you can't cancel here. That's part of a sum, and I get pissed off at students if they start canceling parts of a sum. So you can't cancel. That was a different lesson. You can only cancel if it's a factor, and I can't factor that. So let's leave this alone. So again, I've got common denominators, so I'm simply just going to add the numerators. So I'm going to save a little bit of time and not write that out all up here. I'll just start adding. So 3x squared plus x squared is a whopping 4x squared. I'll combine my x terms for a total of 5x's. And then negative 9, if signs are alike, we add and keep the common signs. So negative 9 and negative 3, negative 12. And the author actually spent the time to write that step out, showing the work is less important. Understanding the process is more important. So fortunately for us, we've already got a common denominator. We'll look at what happens if we don't have a common denominator later in this video. But for now, all I have to do is add. So looking for the x squared terms, I don't have any x squared terms over here, so I just leave 5x squared in the answer. This red term is 2xy's plus another xy is 3xy's. And I believe I have a negative 2y with no common term. And you might think that we're done. And we are done unless we can factor. So earlier I mentioned that you can't cancel parts of sums because that's x squared and that's x squared. So we don't want to do that until we can factor these things. So maybe it's not even factorable, and maybe after I do factor something I still can't cancel anything, but it's worth looking at. So I know that the GCF down here is x, so if I divide each term by x, I'm left with x plus y. So if I could get another x plus y term, and that's the only thing that I'm really interested in, is seeing if I could get another, because I can't factor out an x from each. So I'm really just going to look for another x plus y term, and if I can't get it, then I will default back to saying, well, this was my final answer. So let's look for any common factors. So let's see if I can get a, in order to use that x, I would need a 5x here, and I need a 2 to get this for the last terms. Signs are going to be different, so I've already got a plus, so this has to be a minus. And then I'm going to FOIL this together and check to see if I get the red inner term. So this is 5xy's. The inner is, well, let's see, I need to add a y here in order to get this y squared. So the inner terms is negative 2xy, and lo and behold, 5xy's take away 2xy's is my, so that did factor, so I can cancel, and my final solution is going to be 5x minus 2y over x, because that is gone. So final solution. Good. The author agrees here. So we always want to check to see if we can factor at the end. If you have common denominators, I'm just going to distribute this negative and subtract every term. So you might want to think about this whole term as being subtracted, so I'll put parentheses around that. So that's really a 10x plus 3 minus 3x plus 2. And what I'm really concerned with is that plus 2. This is the part that students will forget. So remember to distribute that negative sign throughout every term, not just the first term. So now combining 10x take away 3x is 7x plus 5 over x plus 5. And I know it's tempting to cancel something here, but we simply cannot. I can't take away the 5s. I can't take away the x's. Don't get tempted to cancel there. All right, so here's some rules that you can follow to find least common denominators. The least common multiple is the same thing as a common denominator. And we're going to look at how to add and subtract maybe some things that don't have common denominators. So in order to add, I need to choose every factor as many times as it appears in each denominator, just like I was doing at the beginning of the video. So let's first of all look at factors of 6 that add up to 5 are 2 and 3. Signs are alike, and we'll add. Looking at the blue term, factors of 21 that differ by 4 are 7 and 3. Signs are different. The larger term is negative. If you're struggling with factor, I would recommend that you go back and watch an earlier video. So now I'm going to choose every factor as many times as it appears in each denominator. So here we go. X plus 2 appears, and it only appears once, or the greatest number of times. And then I have to choose x plus 3. It only appears, the greatest number of times it appears is once. I know it appears twice, but the greatest number of times it appears in the red is once. The greatest number of times it appears in the blue is once, so only choose it once in the common denominator. And x minus 7 appears. So now the goal is to make this yellow look like this yellow. So I got to get common denominators, and I can see that this first yellow is missing a factor, and it's missing that x minus 7 factor. But if you multiply the bottom by x minus 7, you better multiply the top by x minus 7. And when doing so, I'm going to take this 5x, distribute that, and bring down a 5x squared plus 35x. Then I'm going to repeat the process, but instead of looking at yellow, I'm going to start looking at pink. So I'm going to ask, what does this pink miss that this pink has? And it's also missing a factor. And the factor that it's missing is the x plus 2. But if you multiply the bottom by x plus 2, you have to multiply the top by x plus 2. It's kind of like multiplying by a 1. I'm not changing the value of the fraction, I'm just multiplying by x plus 2 over x plus 2. But then I have to remember to distribute the 3 and bring down a 3x plus 6. And now I'm left with just combining like terms. So I'm left with 5x squared, 38x. I better look for, just like we did on the last problem, to see if I could simplify this. So I'm going to look for any common factors up top. So what I'm doing is trying to factor the numerator and see if it's any one of these factors in the denominator. So let's look. Factors of 5 and 6 that add up to 38. And I just realized I made a mistake. I multiplied the bottom here by x minus 7, but here I made a mistake and I put an x plus 7. So I actually need to go back, I'm so sorry, and change this to a minus, that you've never made a mistake before. And then when I distribute this 5x times the negative 7, you get a negative 35. And then combining these terms gives me a negative 32x. That's going to change things. So looking for factors of 5 and 6 that add up to 32, I don't think I'm going to find them because 5 times 6 is the largest that I can get out of here. Then that's only 30 plus 1 is only 31. So it does not factor, but I'm looking for it to see if I could simplify anything, but there are no common factors. So I think I'm done. And the author didn't finish here, so I apologize for that. All right, so let me show you a trick. X5 is this same thing as 5x, but nobody ever writes x5. It just looks funny. So I'm hoping that this 3 minus x looks funny, because usually we write x minus 3. And when something looks funny, it's kind of telling you to do something. And so what this is telling me to do is factor out a negative 1 from this, because it looks backwards to me. And factoring out a negative 1 changes this negative x to a positive x, and this positive 3 to a negative 3. So if you distribute this negative 1 throughout, again, you'll get that 3 minus x, just in a different order. Now this negative 1 can be applied to this negative, because negative times negative is positive. So my new problem says 5x over x minus 3. I now have a plus 2 over x minus 3, because this negative 1 times this negative 1 changes to a positive. So now I have common denominators, and this is just 5x plus 2 over x minus 3. So that's a nice little trick. It's probably the easiest way to work the problem, but if you see 3 minus x, think about factoring out a negative 1. Here's how the author chose to work through it, but again, right there, they're going to get that to be a positive 2. So we're going to try the same thing here. I see that this is backwards. So again, I'm going to factor out a negative 1, giving me a 3y squared minus 1. But then this negative 1 and this negative will change this problem to a positive. And it looks like in the denominator, I now have a common denominator of 3y squared minus 1. And what's left is a 2y plus 5. This negative sign changed to a positive sign. And 7y plus 2. So final solution, combining like terms, 9y plus 7 over 3y squared minus 1. I don't think there's anything to factor here, so we'll just leave that. Good. The author agrees here. They did a little bit more writing than I did. I hope you understand the process. Last example. This one looks funny to me. This looks backwards to me. The rest of them are x minus y's. I'm going to factor out a negative 1 from this, making it x minus y, so it'll look like the others. Sound like Sesame Street. But I'm going to take this negative 1 and distribute to the numerators. So my new common denominator is x minus y. That's what's common to all three. So I'll write down a common denominator. But when I distribute this negative 1 throughout, I have negative x plus 2y. And it looks like I need to continue distributing the negative throughout. So negative 3x plus 3y. And then the last bit, I'm just going to transfer down here, plus 2x minus y. Then looking to combine some like terms, well, let's start with the x's. So I've got a negative x and a 2x will be alike. Here's my y terms. I'll highlight them in yellow. Oh, I've got one more x term, obviously. So I'm going to combine all of the x terms. So negative 1 minus 3 is negative 4. Negative 4 plus 2 is negative 2x. And let's grab the yellow. 2 plus 3 is 5. Take away 1 is positive 4. And it looks like I might be able to factor. So what I'm doing now is, if you end up with an answer like 2/4, we usually like to simplify it. So we have the correct answer, but I'm wondering if I could factor this out and get another x minus y, because if I could, then I could cancel these x minus y's. That's the goal. So let's see if I can accomplish that, because it's not always possible. So the GCF up here is maybe a 2 or maybe a negative 2. So if I pull out a negative 2, that'll give me that x, which I so desperately wanted, but I don't think, if I divide through by negative 2 here, I think I'm going to get a negative 2y, and I'm close to being the correct answer, but I would just stick with the black. Negative 2x plus 4y. you could leave it in this blue. If you wanted to leave it in factored form to prove to me that you've actually explored this as an option, the red would be a good solution as well, because it's a little bit more intuitive that this is the final solution because there's no common factors. I think the author just chose to not explore that last little option. I hope this video was helpful. If you have any questions, feel free to email me.